All right, we're hitting EIGRP now, and we're going to lead off with some theory and some exercises to help you cement this theory in your head. Don't use actual cement, that would not be good. And then we're going to have plenty of live labs. So as always, I think that's one of the beauties of these on-demand courses is that, not bashing boot camps, but it's not like you're in a classroom for 5 days and you're just trying to remember all this stuff because you only saw it once. You can see this as many times as you want. And the great thing about that is that it really helps you absorb it when you see it the second time around. And that's especially true of EIGRP. So we have a lot of features here to discuss. And then, like I said, you'll see them all live on the rack as well. Now, EIGRP has been called a lot of things. And one is it's been referred to as a hybrid protocol. This term irritates some people. I'm not sure why, but it's a hybrid of distance vector and link state protocols. Some people just call it a super duper whoop-de-doo advanced distance vector protocol. Maybe just advanced. I threw the other stuff in myself. Or none, or both of the above. Okay, glad you got that down, right? Well, personally, I think hybrid is accurate because it's got a little bit of distance vector protocol behavior and a little link state protocol behavior. And in this section, you'll see both of those behaviors demonstrated, both of those behavior types, I should say. Now, one big change for us, EIGRP used to be called Cisco proprietary because it was. Cisco kept EIGRP to itself. You couldn't run it on other vendor routers. And that was one differentiating point between OSPF and EIGRP. OSPF you can run on anybody's routers, but you can't run EIGRP on it. Well, that is no longer the case. That's the official word, and that is a big change from the last version of the CCNA exam. Now, Cisco proprietary or not, EIGRP brings a lot to the table, as well as major advantages over RIP and IGRP. And if you never worked with IGRP, I'm going to tell you something, you didn't miss a thing. It was about as smart as RIP version 1, which is to say not smart at all. You couldn't do much with it. And the only reason we even mention it is to tell people where EIGRP came from. It's actually obsolete. It's been obsolete for a while as of this recording, and it's not supported on current Cisco IOSs. So even if I wanted to show it to you, I literally could not. So what are these advantages? Well, EIGRP gives us very rapid convergence when there's a change in the network, especially with a lost route. Because the great thing with EIGRP is that backup routes, which are called feasible successors, are calculated before they're actually needed due to the loss of a primary route. And in EIGRP speak, we call primary routes successors. If these are new terms to you, you got to get them down cold. Successors, your primary route. Feasible successors are your backup routes. Now, EIGRP considers the bandwidth of a link when computing its metrics, rather than the less than accurate hop count metric of RIP. And I'm going to have more on that for you later in this section. It does offer multi-protocol support. It supports variable length subnet masking, VLSM, and classless interdomain routing, CIDR, where RIP version 1 and IGRP did not. Now, full EIGRP routing tables are exchanged, but only at one time, and that's when you would expect it, really, right after an adjacency is formed. We have no problem with full routing tables being exchanged then. It's with RIP versions 1 and 2 where we're sending out full routing updates every 30 seconds that we have a little bit of a problem. EIGRP doesn't do that. After that initial exchange of routes, EIGRP updates are going to contain only the routes that have actually changed. The contents will reflect the changes. And these updates are sent only when that change occurs. So that's a big, big advantage for EIGRP. We still have some kind of heartbeat, though. We do have a hello packet. EIGRP uses hello packets, which are multicast to 224.00.10, an excellent address to have down, to keep, to establish, and to maintain neighbor relationships. Now, the RTP, the Reliable Transport Protocol, is used to handle the transport of messages between EIGRP-enabled routers. Now, EIGRP uses autonomous systems to logically group routers. In OSPF we have areas, and in EIGRP we have autonomous systems. Now, EIGRP routers that are in separate autonomous systems, as we'll see, not only will they not exchange routes, they won't even become neighbors to begin with, and obviously I'll put an S there. They won't even become neighbors. So for an EIGRP neighbor relationship to be established, The routers must receive hello packets from each other. They have to be on the same subnet as the potential neighbor, and the autonomous system number must match. Now, we do have EIGRP authentication. It's not part of the CCNA course, but naturally, if you have that in place, the password must be agreed upon for an adjacency to form. Otherwise, what's the point of having the password? Now, as with OSPF, once the neighbor relationship is present, it's the hello packets that keep it alive. If the hellos are no longer received by a router, the neighbor relationship will eventually be terminated. Now, like OSPF, EIGRP has fixed times for sending hello packets. And that is broadcast, point-to-point, serial, and high bandwidth links will send EIGRP hellos every 5 seconds. So we're going to find a problem pretty quickly. And anything over T1 is considered to be a high bandwidth link by EIGRP. Multi-point links running at T1 speed or less are going to send hellos every 60 seconds. But there are some major differences between OSPF and EIGRP, and one of them just with terminology. You will not see dead time when we're looking at our EIGRP neighbor relationships on the live equipment. You're going to see hold time. But if that hold time ticks down to 0, it's the same thing as dead time. With OSPF, you're going to lose the adjacency. The EIGRP hold time is 3 times the hello interval by default with EIGRP, of course. OSPF's dead time we know is 4 times the hello interval by default. EIGRP neighbors do not have to agree on the hello and hold timers to become neighbors. And we saw, of course, with OSPF, that was one of the situations we did some troubleshooting with, that we did a mismatch purposely on the hello and dead times, and we saw the adjacency go right down. I strongly recommend to you, though, and so does Cisco, that if you change the EIGRP timers on one router in an AS, please change them to match. This isn't something we do real often, but I will say this. If you just change them in one place and you make it just really out of whack with the other ones, you can end up losing adjacencies. Because if you have one router that has a hold time of 15 seconds and the other one has a hello time of 60 seconds, you're going to have some problems there. In the very next video, we are going to hit the successor and feasible successor, two terms really that are at the core of EIGRP understanding and, of course, passing the CCNA. So I'll see you in the next video, and we'll talk about those.